All right, let's dive right in. We're going to talk about something today that it might just completely flip how you see the world. And I mean that literally. It's something that challenges the most basic thing we think we know about reality.
Yeah, I know how that sounds. It sounds completely absurd, right? I mean, you're sitting there, maybe in a chair, you can feel your feet on the floor, you might be holding your phone right now, you feel all of that. But what if I told you that feeling, that sensation of touch, is not at all what you think it is?
That's the big idea right there. The whole concept of solid is basically an illusion. This world that we interact with every single second of every day, it's built on something else, something you can't even see.
Okay, so to really get our heads around this, let's start with something super simple. Picture this. You knock on a wooden desk. What happens? You hear that thump. You feel the impact on your knuckles. It feels solid. But what's really going on, down at the atomic level, is a kind of amazing deception.
And I mean this, not one single atom in your hand ever actually makes contact with a single atom in that desk. No way. So, what in the world is going on? What is that feeling? What are we actually sensing?
Well, the answer, as it so often does, takes us into the kind of weird world of quantum physics. At the very center of this whole illusion is this incredibly powerful, invisible, think of it like a force field. And it's this force field that's running the show for pretty much every physical interaction.
So this invisible force has a name. It's called the normal force. And here's the gist of how it works. You know how every atom has that cloud of electrons buzzing around it? Well, those electrons are negatively charged. So as your hand gets super close to the desk, the electron clouds from your hand start to push against the electron clouds from the desk. It's exactly like trying to force the same ends of two magnets together. You feel that pushback, right? They just will not touch.
And that's the key right there. When you think you're touching something, what your brain is actually processing, what your nerves are feeling, isn't a solid surface. It's that incredibly strong electromagnetic repulsion. You're feeling the force, not the object. Think about it. The chair you're sitting on, it's not holding you up because its atoms are physically stopping your atoms. Nope, it's holding you up with this invisible cushion of pure electromagnetic energy. In a very real sense, you are floating. We are all floating, just a tiny distance above everything we touch. All right, so this is starting to make a weird kind of sense, but it brings up a huge, obvious question, doesn't it? If this force is strong enough to keep me from falling through my chair, why can I punch my hand straight through a thin piece of glass? What gives?
Yeah, let's really look at this. On one side, you've got this normal force, which is basically the foundation of our physical world. It keeps us from just sinking into the floor. But on the other side, it seems to just fail sometimes. It seems super weak when you come up against certain things. It feels like a total paradox.
This really is the core puzzle here. How can we have this unbelievably powerful force that stops atoms from ever touching, and at the same time we can break things, we can smash through stuff? How do those two realities coexist? And this is where it gets really interesting. It turns out the force isn't actually failing. The repulsion is always there. What's happening is that when you push on something like glass, you're applying enough energy to literally break the bonds that hold the glass atoms together. You're not overcoming the repulsion, you're just pushing the atoms apart from each other. So an object's solidity isn't about the atoms themselves, it's about how strongly they're all stuck together. That's why a chair with its strong atomic bonds can hold you up, while a pane of glass with weaker bonds shatters. It's a known puzzle for sure, with some really deep roots in material science.
So, okay, let's pull all this together. What does this actually mean for us, for how we see the real world every day? Let's break down what we've learned.
All right, here are the big takeaways. First, the world you think is so solid, it's not. It's mostly empty space. Second, that feeling of touch is really just you sensing an invisible electromagnetic force pushing back. Third, atoms never, ever actually touch each other. And finally, how solid something feels is really all about how strong the bonds are holding its own atoms together.
And really, that's the bottom line. Our entire physical experience, every step we take, every single thing we hold, it's all just this complex dance of invisible forces and energies. The reality you experience is being shaped by things that you literally can't see and will never, ever truly touch.
Which kind of leaves you with a big question to chew on, right? If our most fundamental sense, the sense of touch, is really just our brain's interpretation of an invisible force, what else about our reality is just a matter of perception? Something to think about. Thanks so much for joining me for this one.